All right, so now we're going to get into 5.3, which is our quote unquote special factoring. It's just more factoring. This next one, or this first one that we're going to do, I will say is the only one that's like I would call special. In other words, you don't have to do it. This is an optional method that you can choose to do. It's an optional method for factoring trinomials. So if you want to do 5.2's AC method for these, that's absolutely fine. But these are going to be some special trinomials that are called perfect square trinomials. So first thing we're going to do is start with the answer, go back to the question, and then be like, how could we recognize that these are going to factor like this? So if I gave you a question like x plus 3 all squared, that would mean that I want you to do x plus 3 times x plus 3. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. Combining like terms, I get x squared plus 6x plus 9. If this was the question, this would be the answer. So there's something about this trinomial that means it will factor to a binomial squared. Okay, so same thing here. Okay, let's multiply this one out. So this would be 2x minus 5 times 2x minus 5. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 10x plus 25. Combining like terms, I get 4x squared minus 20x plus 25, sorry. So what is it about these two trinomials that allow them to factor to 2x minus 5 all squared and x plus 3 all squared? Well, you'll notice that when I was multiplying them out, these two middle terms were always the same. So when they added together, I got this number that was double these two being multiplied together. So I got 6x, I got negative 20x. And that half of this, so half of the 6 would give me that 3, which is what is squared to give you the 9. And I'm sure there's a better way of phrasing that. I just don't have it yet. But what it is that these are perfect square trinomials because, number one, they're trinomials. Number two, the front and the back coefficients are positive perfect squares. So the number in front of the x squared is a perfect square. The number on the end is a perfect square. Same thing here, 4 and 25. And if you're not comfortable with your perfect squares, okay, I've listed them here just to get you used to them. So let's just take a minute just to make sure we can recognize positive perfect squares. So for example, 1 squared is 1, 2 squared is 4. I want you to pause the video and try to fill out the rest of this. Okay, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121, 144, ooh, 169, which everybody remembers for some reason, and then 14 squared is just reversing those, and then 225 and 400. Don't stress if you didn't know these. As long as you knew to 100, you're fine. These pop up occasionally, so I feel like it's good to see them once. You'll also notice that if you go to your formula sheet, so here we go, I just opened your formula sheet, you'll notice that those perfect squares are the diagonals, so 1, 4, 9, 16, and so on. So if you don't have them memorized, but you have this out when you're doing the factoring work, you can look for those there. Okay, so first things first, they have to be a trinomial. The front and the back numbers have to be perfect squares, and then here's that weird part. If you were to take half the middle term and square it, you would get AC. So in other words, if I took half of 6 and I squared it, I get 9, which is AC. Same thing here, if I took half the middle term and I squared it, that would be 10 squared, which is 100. That's the same as AC. So I feel like the hardest part about these is actually recognizing something's a perfect square trinomial. And to be fair, I don't always take the time to check. I just tend to just go, oh, it's a trinomial AC method. But every once in a while, I'm like, oh, wait a minute, that one's a perfect square trinomial. And I actually, to be fair, recognize it in a bit of a different way. It's the same, but a little bit backwards. And I'll show you what I mean by that. So let's check to see if these are perfect square trinomials. So technically, the test is that they're trinomials, which they all are. And then A and C have to be positive perfect squares. 1 and 25, all good. 4 and 9, all good. 9 and 1, all good. Then here's the real test. If you take half the middle term and you square it, do you get AC? So in this case, AC is 25. Half of 10 is 5. Squared is 25. So this one is a perfect square trinomial. Same thing here. So AC would give me 36. And to check, I would do half the middle term squared. Half of 16 is 8. Squared is 64. So this one does not work. This one's not a perfect square trinomial. This one I'd have to do the AC method. And then same thing here. AC is 9. Is that half the middle term squared? Yep, I'm all good. So that's one way of testing if they are perfect square trinomials. It's the way that they teach in chapter 5, getting you ready for something that we're going to do in chapter 8. But there is another way to check as well, which I'll show you in a second. But how do you then factor? So the first thing is you recognize it's a perfect square trinomial after you've greatest common factored. And then to factor, it's pretty simple. You literally draw a sign or draw two brackets and make sure it's squared, right? And then you take the sign of the middle term and you put it in there. So this is going to be a something minus something all squared. To find the somethings, you literally take the square root of the front term. So the square root of 4x squared is 2x, and the square root of the last term, which is 1, and you're done. So 4x squared minus 4x plus 1 factors to 2x minus 1 all squared. Now, if you're like, I just want to show you AC one more time. Well, probably not one more time, probably lots more times. If I went to go factor this one using the AC method, I'd say, okay, my target number is 4. Two numbers that multiply to give me 4 and add to give me negative 4 are negative 2 and negative 2. This is my other sign that it's a perfect square trinomial. Anytime you do AC and you find that the two numbers that multiply to give you AC are the same with the same sign, that's another trigger that it's a perfect square trinomial. That's when I've been starting to trigger that I'm like, ooh, I could just do that. Otherwise, you do AC. So 4x squared, and then split up that middle term. Oof, my writing is awful right now. And then group. So out of the first group, I can pull out a 2x to be left with 2x minus 1. Out of the second group, I'm going to pull out a minus 1 to be left with 2x minus 1. And then I'm going to greatest common factor. And then maybe you recognize that they're both the same bracket, so then I can write it as 2x minus 1 all squared, which you don't have to. Like if you left it here, that would be fine. But look at the difference in the work. One, you had to recognize it was a perfect square trinomial, which is work, but then the factoring is really easy. Number two, I didn't recognize it was a perfect square trinomial. I did AC, gives me the same answer, just a little more work. So it's kind of up to you. Okay, let's try these next two. So the first thing we want to do is recognize it's a perfect square trinomial. So two ways of doing that. One way, AC is 49. The two numbers that multiply to give me 49 and add to give me negative 14 are negative 7 and negative 7. That's my first trigger. The second one, just to reinforce it, is that half the middle term squared, is it 49? Yes. Oh, those 4s. So I know I'm good. So then to factor it, literally draw a bracket squared, take the sign off the middle term, and then square root. Square root of 49z squared is 7z. Square root of 1 is 1. Okay, or like I said, AC method will totally work. So if you want to ignore this first trick or this first special factoring, you totally can. All right, what about this one? Okay, let's check it again. So 9 times 64. 9 times 64 is 576. Ooh, yuck. Okay, so maybe this one I check AC. So I go 48 divided by 2 all squared, which half of 48 is 24. Squared is 576. Okay, it is a perfect square trinomial. The other way of checking is you go to do the AC method and you're like, what are two numbers that multiply to give me 576 and add to give me 48? And you're like, oh, 24 and 24, right? A little bit more work, but it's probably what you're going to be in the zone of doing. Okay, so either one of those are your triggers that this is a perfect square trinomial, meaning I can factor it by drawing a bracket squared, take the sign of the middle term, then take the square root of the first term, take the square root of the back term, and call it good. Awesome. That is perfect square trinomials. And again, if you go to do this homework and you're like, I don't get it, AC. It never hurts to practice AC over and over and over again because it's the one thing that people do kind of struggle with in this course.